Hopefully this is all review, but like I said, safe space. If it doesn't seem like review, just ask questions and we'll go from there. All right, so here we go. Law of exponents. This is a recap activity. I didn't create this activity. I took it from someone. I don't know who I took it from. It just gave it to me like this. They color coded it. It looks okay. I mean, I think it wraps up the ideas okay. I'm just not a big fan of whoever did this, how they did the colors here like that and the black here, but that's fine. Not a big deal. When we get there, we'll tackle that. So here it is, guys. So we have first we have some products here, and it has 2 to the third times 2 squared. Relax. So that 2 to the third, and I'll color code it. I'll put that in red. That 2 to the third, that just means 2 times 2 times 2. That's what it means. And then this right here, I'm going to put this one in blue. That 2 squared just means times 2 times 2. So when you see expanded form, that's there it is. That's expanded. How many 2's do you see? So as a single power, you would write 2 to the power 5. That's all they want. That's it. That's really it. On Delta Math, if you decide to go that route later on, if you want more practice, on Delta Math, they're probably going to want the number, like what 2 to the 5th is. Relax. It's really easy to evaluate. So let's do it like orally real quick. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is? 32. So there it is, 32. If you want to, like if you're a visual learner, like Chop, I got to see that. So here it is, 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. So check it out. I'm going to go 2 times 2, and 2 times 2 is? 4. So there it is. I already used these two, so scratch them out. And then I'm going to bring this one right, 4 times 2. So that's this one right here. What's 4 times 2? 8. So I'm going to scratch this one out, put an 8 right here. Well, I guess I shouldn't put equal because I don't want to do a linkage error. So now I have these two right here. What's 2 times 2 again? 4. Okay, so I'm going to write 8 times 4. Boom. What's 8 times 4? 32. There it is. Look at that. You didn't have to do it that way. Maybe that's not conventional. Maybe I should have done 4 times 2, which is 8, and then 8 times 2, which is 16, and then 16 times 2, which is 32. See, there's so many different ways to do it, guys. So don't ever let a teacher tell you got to do it this way. No, you don't. You can do it however you want, whatever makes sense to you. Just make sure that you're using logic. Okay, so let me do a timeout real quick. It is very, very easy to trick your teachers that you know math by being a robot, by just memorizing some stuff. Try really hard not to be a robot because all the concepts start building up on each other, especially as you go higher up in math. Now, AI is here. It's not going to go away. That's fine. If you use AI to help you with your math homework, that is okay. It's helping you. What's not okay is using AI to finish your homework and do it for you. Does that make sense? Now, if you're using it like to help out, like, oh, let me see the steps. Like, okay, I see what they're doing. If you're using it like a tutor, like someone being there, but instead of a person, it's a laptop and it's telling you step by step. I think that's okay. Now make sure to try some of on your own to see if you can do it. And here's what someone gave me an analogy. I didn't create this one. Someone told me this analogy, and I thought it was absolutely perfect. But this was not necessarily as a student. This was more like in the work environment. So someone said, if you're using AI at work, that means that your job can be replaced by AI 100%. Because all it is just you and whatever, and you're using AI to work. So what's there to stop you from your employer saying, okay, you're done. We'll just automate yours with AI. Is that making sense? So if you use AI, and I loved it when she told me that, I'm like, oh my God, I'm going to use that. If you use AI in all your education and that's all you know, AI, and you never use critical thinking, then why should an employer hire you over AI if AI is doing whatever, what you're doing? You're just typing stuff in and AI is doing it for you. Do you guys know what I'm trying to say? Critical thinking is never going to go away, guys. Make sure you set yourself up to always use your analysis, logic, critical thinking. If you use your critical thinking, you'll be safe no matter what. Cool? Okay, sorry guys. Should I edit that out or should I leave that in? I don't know. Okay, I'll leave it in. All right. W to the third power times W to the fourth power. So I'm gonna color code this. I'm gonna put that in red. So W to the third power. W times W times W. All right, so this one right here in blue, that says W to the fourth, so times W times W times W times W. Make sure to put a dot. If you don't put a dot, that still means the same thing that you're multiplying. How many W's do you see? 7. So I'm going to write W to the, 7. There it is. See?
So technically, you're just adding the two exponents together.
That's what I'm doing. When I get to here, that's my conjecture. You guys have geometry. All right. Cool or not cool? Check it out. Look at this. That P to the fourth, 1, 2, 3, 4. If you don't put the dot, that's fine. It still means that you're multiplying. And then there it is. This is in blue, so this one's in blue. How many P's do you see? It's okay. Everyone gets tired after lunch. How many P's do you see?
5.
So I'm going to write what?
5.
P to the 5. Yeah, P to the 5. See? Look at this one. Oh, child, this one has parentheses. Relax. Relax. So here it is. This is my red parenthesis. That says 3 squared. 3 times 3. That one has x to the 4th. So I'm going to write 4 x's. 1, 2, 3, 4 as a product. Make sure you put a little dot. Or you don't have to put a dot. As long as you don't put a plus or a minus, because then that changes everything, right? So there it is. That one's in red. And here is the one in blue. If you want to use colored pencils, or if you have a pen and a pencil, or you don't have to do any of this if you don't want to. 3 times x. Are we still okay? Okay. How many 3's do you see? So I'm going to write 3 to the 3rd power. How many x's do you see? X to the 6th power. Now, if this were Delta Math and it said simplify, they probably want you to write what 3 to the 3rd power is. So I'm going to put an equal sign. Chav, how do I find it? Let's see. 3 times 3 times 3. You guys ready? What is 3 times 3?
9.
So I already used those. What is 9 times 3?
27.
There it is, 27. So this is 27 x to the 6th. Is this making sense? Okay. It has to make sense, guys, because if it doesn't make sense, then you're just going to become a little robot and, like, I don't know, this is what he did, but I don't know what he's doing. I'm just doing what, okay, I'll stop. 5, I'm doing this one in red, x to the 4th, so I'm going to put 1, 2, 3, 4. This time I didn't put little dots. It's still the same thing. It means multiply times y. So there it is. And then I'm going to put this one in blue, and I'll slow down in case I'm going too fast. I'm going to open a parenthesis. I'm going to put a 2, and that says x squared, so I'm going to go x, and I'm going to say y. There it is. So there it is expanded. And then I'm going to go 5. Okay, I'm going to slow down. What is 5 times 2? So I'm going to put 10 right here. How many x's do you count? 6. So I'm going to put x to the 6. How many y's do you count? So I'll put y squared. How do we feel? All right, now it says here, it says, using the statement you wrote, express the shortcut algebraically, product of power with the same base property. So there it is. This is called a base. So if I have the same base and I multiply, what do we do? You said it earlier. What do we do?
Oh,
We add the exponents, m plus n. And I'm going to put parentheses there so we make sure that that's an exponent. And there it is, guys.
I had a question for number 5.
Yeah, hit
So
me.
the exponent near the x, it's only accounting for the x, right?
Yes.
Okay. Because I thought earlier for number 4 was 3x times 3x. I didn't know it was just the x. I got confused with that.
Yeah, let's see. So yeah, we're just counting that. 1, 2, 3, 4, 5, 6. So then this one, 1, 2, 3, 4, 5, 6. We're good. Cool. Yeah, no, keep hitting me, guys. Hit me. Or don't hit me like physically, but because that's not bueno. All right, are we okay so far, guys? Yeah. All right, here we go. Power raised to a power. Relax, we're fine. Check it out. So you see those parentheses? So this says that I have 4 of those. So I'm going to put a parenthesis, and look, that on the inside, that says 2 squared. So that means I have 2 of those. So I'm going to go 2 times 2. There's 1. And I'm going to repeat this 3 more times. So I have 4 of those. So 1, and then 2 times 2. There's a second one. 2 times 2. There's my third one. 2 times 2. There's my fourth one. Does everyone see how we did this? How many 2's do you count? So there it is. So I'm going to write this as 2 to the power 8. Now let's see if we can do this just thinking about it. So 2 times 2 is, and then 4 times 2, and then 8 times 2, and then 16 times 2, 32 times 2, 64 times 2, 128 times 2. There it is. Look at that. No calculator, no nothing. By the way, side note. This is just a side note. I want to always make sure. Have you guys ever seen those numbers before? Let's see. 2, 4, 8, 16, 32, 64, 128, 256, 512. Those look familiar. They probably won't call that 124. They probably call that 1 terabyte instead of just 124. But have you seen those numbers before? These ever? Somewhere? Where do you see them all the time in what? The computer, the RAM, memory, 64 gigs, 128. Why do you think those numbers come out all the time? Why?
Because it's like the easiest square. So
because computers work with zeros and ones. That's 2. We call that binary. Does any of this sound familiar to you guys? So this is why those numbers come out, like the number of the memory, the RAMs, how much RAM you. Well, there's something tricky because there is something such a thing as like 24 gigs, and but that's different. When you go to computer science, you'll figure this out. If you don't know what I'm talking about when I say binary, talk to Miss Kilgore. Miss Kilgore, can you teach me binary? And she'll teach. That's my impression of you guys talking to Kilgore, and I'm sure she'll teach you binary and all that good stuff. That's not the only base. I'll stop talking about that because I'll go forever on that. I don't know. Okay. I don't know if you've noticed, but my mind's always racing. There's always so much stuff that I have up there, guys, that I'm trying to get out. I don't know what it's called. Is it ADHD or if you ever have a conversation with me, I can change my stories from one thing to another, and then I'll go back to the story, and then you just kind of have to keep up and try to put it all together if we ever have like a conversation that's non-math. Usually with math, I'm pretty good about keeping in that same, but as you just saw right now, look, I just switched it to binary and all that. Okay, let's get back to this. All right, here we go. 5 to the 3rd raised to the 4th power. So here we go, guys. I'm going to go 5 times 5 times 5. That's what it means, 5 to the 3rd. And I'm going to put 4 of those. That's 1. 5 times 5 times 5, that's 2. 5 times 5 times 5, that's 3. Oh, I didn't write small enough. 5 times 5 times 5, that's 4. And I bled a little bit into the other column. That's okay. How many 5s do you count? So this is going to be 5 to the, and I don't know what that number is. That's a big number. I'm not going to bother. Child, why did you do the other one? Well, because the other one was a small number. I could do that one.
But with delta, like say if we were doing some delta math, would it ask for simple?
It would probably want the number. I would just click on the little calculator tab because delta math has a little calculator tab, and I would just go 5 to the 12, and then whatever that number is, I'd go cut, paste. So, all right, you guys ready for the next one? Here we go. Number 3, it says W cubed raised to the 4th power, open parenthesis, put 3 W's. W, 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 close, and then make 4 of those groupings. W, 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 W. I kind of sound like a speaker that's trying to give a website, but you're broken and you just keep repeating W's. How many W's do you count? W to the 12. What's my conjecture? What do you guys notice? Yep. If it's a power raised to a power, it's going to be A to the M times N. Cool or not cool? Cool. All right, let's go to the next one. Let's see if we can start going through this kind of fast. So expanded form, 2 to the 5th. 1, 2, 3, 4, 5. So 5 2s. That's in my numerator. 2 to the 3rd. 1, 2, 3. 3 2s. Multiplying and dividing are inverse operations. So that means we can just cancel them like this. Bam, bam, bam. Think of it as like 2 divided by 2. So that's like a 1. So there it is. How many 2s do I have left? So you're going to write this as 2 squared. Can you write that as 4? Of course you can. But there it is. It just says single power. So there it is as a single power. Are we doing okay? Ask me, hit me. Are we okay? Are you sure? You're not just saying that just... Okay, perfect. Y squared. You got to tell me this. Y squared. How many 2s do you see? So because I have 2 of them, I put that 2. If I would have had 3 of them, I would have put 3. If I would have had 4 2s, I would have put a 4. But I have 2 of them, so I put 2. And ask me if that still didn't make sense. See, 2 times 2 times 2 times 2. How many 2s do you see? So I'm going to go, that's the same thing as 2 to the 4th, because that's what the rule is. So when you say 2 to the, let's say squared. When you say 2 to the 4th, that means, oh, it's 2 times 2 times 2 times 2. You're doing that 4 times. Hit me, miss.
I got it.
Okay, well, no, I'm not, well, not right now. Like, just, hit me, like, don't hit me, but hit me, like, okay. If you guys could read my mind, guys, I really do want you guys to ask me questions. We had 100% of my 2023. Everyone in that class qualified, and that's because they asked me questions. Anytime they don't know something, they just ask. So ask me, guys. That way we can, like, this is a safe space. I promise. I would not be a teacher if I were to be judged. Imagine if someone asked, man, how horrible. I hope you never had that teacher. That, miss, you should know that, miss. Why are you asking that question? You should know that. Man, if you had that teacher, I am sorry. That they shouldn't, you shouldn't be a teacher if you're gonna. For those of you that are gonna be future teachers, guys, like, it's okay. Like, you're part of you're supposed to guide. You're supposed to help. So help. Okay, I'll stop. You guys ready for this one? Okay, this says h to the 8th, so I'm gonna go 8 times. H. I already lost count. 1, 2, 3, 4, 5, 6, 7, 8. So there it is. And on the bottom it says h to the cube. 1, 2, 3. How many h's can I cancel? 3. Bam, bam, bam. How many h's do we have left? So that's what I'm going to write. H to the 5th power. Bless you.
Thank you.
Are we okay? All right. Let's go to number 3. I know that there's a lot of them in there, W9. So let's put 9 of them in there. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then there's 4 H's. 1, 2, 3, 4. So there it is. That's my numerator. And here it comes my denominator. 2 H's, H, H, and then 3 W's. W, W, W. There it is. All right. Yes, hit me.
Is the denominator ever going to have like more letters or numbers than the numerator?
Yeah. As a matter of fact, that's my side note that I'm going to do in a little bit. So yeah, that does happen. Whoever wrote this did not put that situation, but I'll put that in there in a little bit. All right. How many H's? Well, I already said H, so let's start with it. How many H's can I cancel? So bam, bam, cancel 2. How many W's can I cancel? So bam, 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 cancel 3. You don't have to do the sound effects. How many W's do you have left? You have, no, I think you have 1, 2, 3, 4, 5. Oh yeah, 6. 6. Sorry, guys. So W to the 6. How many H's do I have left? H squared. Are we still okay? All right, number 4, there's too many D's and there's too many T's. I'm not going to expand it, but let's look at that 12 over 10. We can get 12 by doing 6 times 2. We can get 10 by doing 10 times 2. What's going to cancel? The 2's. Oh, and I said 10, right? 5 times 2. Yeah, sorry. I'm going to edit that out so my video looks perfect. No, I won't edit that out. I make mistakes. 5 times 2 is 10. 6 times 2 is 12. Is everyone okay? Sorry if I confused anyone. No one's confused right now, right? Okay. Look what cancels out. The 2's cancel out, and I have 6 over 5. Do you guys see that? So that's what I'm going to write right here. 6 over 5. Now, notice I have 15 D's in the top, and I have 8 D's in the bottom. How many D's can we cancel? We can cancel 8 D's. You're giving me, that's how many we have left. We can cancel 8 D's, so bam, that goes away, and subtract 8 from the 15. So that's going to be how many? 7, so there it is. I have 7 T's in the top and 1 T in the bottom. How many T's can I cancel? 1, so I'm going to have how many? There it is. So I'm going to write T to the 6. How do we feel?
So I just want to confirm, for
Yeah.
the numbers, instead of subtracting, you're trying to find the least, the common multiple, or just trying to find the product?
Yeah, well, I guess you can say common multiple. I mean, 6 times 2 is 12, 5 times 2 is 10, and then these 2's cancel, and then this is what you have left. Your teachers might have called it in the past, maybe like reduce it. Like, oh, what goes into 12 that also goes into 10? 2. So 2 goes into 12 6 times, 2 goes into 10 5 times, and there it is. It's reduced. So it just depends. Different teachers call it different things, but it's all essentially the same.
Okay, thank you.
Oh, you're good, you're good. Keep them coming. So here it is, guys. You guys already told me. What do we do with those exponents? We subtract them. Now, see if you can write this on the margins. I'm going to do that special case. So put a SN. SN stands for side note. I'm going to write x squared in the top, and I'm going to write x to the 5th in the bottom. Using this rule, 2 minus 5 is just going to be negative 3, right? But notice, and this is not a linkage error because all these are equivalent. That says x squared, so I'm going to go x times x. And on the bottom, I'm going to go x times x times x times x times x. Did I put 5 there? 1, 2, 3, 4, 5. Yeah. So check it out. How many x's can I cancel? 2. Notice that you have 3 of them in the denominator. So this is equivalent to saying 1 over x cubed. So Chab, what did we just learn right now? What's going on with this? If you have a negative exponent, you can turn it positive. If you have a negative exponent that's in the numerator, you can turn it positive by bringing it down to the denominator. Does that make sense? So let's do another side note, and let's see if you guys can do this. I'm going to change my color. Side note. So what if I have 1 over x to the negative 2? How do I turn this to a positive if I want a positive exponent? By bringing it up. Does that make sense to you guys?
Yeah. So like flip-flopping?
Yeah, I guess you can call it flip-flop.
What was it called? How do you reciprocate?
Be careful with the word reciprocal.
Dang it.
Let's see, I guess.
There was a word for the tipping.
Yeah, because reciprocal would have been x to the negative 2.
Oh.
So you just got to be careful, right? I guess flip-flop's probably a good word. So, and if you want to turn an exponent, and the next yon's a demerit. I'm kidding. That's a joke. I shouldn't joke with you guys because you guys don't know me that way. Is this making sense to you guys, or does that not make sense? You want me to do something really quick so you guys can see this? Okay. So don't write anything down. Just listen. So let's see what I have. X to the negative 2 in the bottom. Okay. So I'm gonna write it like this. Let's see. I'm gonna write it like. Okay. I'm gonna use the rule. So I'm gonna write x to the 4th over x to the 6th. Using my rule, look what you just told me. Where are you? Right here. Look what you just told me. Anytime you have a fraction, I can just do the top minus the bottom, the exponents, right? So look at this. 4 minus 6. What is that? So I have negative 2. Look what would have happened if I would have taken this and just expanded. X dot X dot X dot X. That's the numerator, and I have 6 on the bottom. 1, 2, 3, 4, 5, 6. How many X's can I cancel?
4.
And look at that. Those are in the bottom. So I put a 1 in the top and I put an X squared in the bottom. And now look, that X squared, look what happened. That X to negative 2 turned into a. Okay, you guys probably want to see it the other way around too, right? So let's see. Let's do, because what did I do? I did X to negative 2, bring it up. So I'll do this. What example did I do over here? I already forgot. Oh, yeah. I had a negative 2 on the bottom. Well, that means X squared on the top. So see, that's kind of lame. That X to negative 2 means 1 over X squared. Which that's what I was trying to do here. See, there's 4 there. 4 minus 6 is X to negative 2. Is this making sense to you guys or not? Like, okay, because I want to make sure, because if it doesn't make sense, okay. So we're good. You're not just telling me that just so we can move on. Are we good? For sure. Okay. All right, here we go, guys. Let's go to the next page. Turn the page. And now we're just using the properties. And I know this is not the most exciting. When you guys came over here on day 1, did you think you guys would be doing this stuff? Oh, okay. But now we are. And are you guys happy that we are? Or, I mean, we got to. What would you guys rather be doing? Would you rather be home?
Yes.
And do what?
Sleep.
Relax.
But how much sleep do you need?
We need it all before school starts.
All right. Well, don't worry, guys. It's only 1 week, and then we'll be out of here soon, and you guys can have your fun the next 2 weeks, next week and a half. All right, 2x to the power 4th. 2x, 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 2x. How many 2's do you see? 2 to the 4th power. How many x's do you see?
4.
X to the 4th power. There it is. That's it. This is to the power 3, so I'm going to have 3 of those. Negative 4a, negative 4a, negative 4a. Are we still okay? Negative times a negative times a negative is still going to be a negative. How many 4's do you see? Or I guess how many negative 4's do you see? So negative 4 to the 3rd power. How many a's do you see? A cubed. If this were to be a delta assignment, they'd probably want you to simplify that. Negative 4 to the 3rd power. So negative 4 times negative 4 is a positive 16. And then positive 16 times negative 4, what's that? 16, 32, is negative 64. Negative 64, a cubed. I got to go in pieces. Are we still okay? Okay. All right, let's go to the next one. This one's a good one right here. That's to the power 5th. I'm going to try to write small. So 3 h's and a t. So h, 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 t, and put 5 of them. H, 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 t, H, 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 T, H, 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 T, and I need one more, H, 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 T. This one bleeds in a little bit to the other column, but that's okay. How many H's do you see? So there it is, H to the 15th. How many T's do you see? T to the 5th. How are we feeling, guys? All right. Yeah, see, this is 2/5 to the power 2. Don't worry, we'll be done pretty quick. 2 over 5 times 2 over 5. So what do I have? I have, how many 2's do you see in the numerator? How many 5's do you see in the denominator? There it is. All right, this one has a 3 there. So here we go. Relax. We're okay. 3 over, that says y squared. So that's y because we're expanding it. And I'm doing this 3 times. 3 over y 3 over y. Does everyone know what we're doing, guys? Okay. How many 3's do you see? So I'm going to write 3 to the third power. How many y's do you see? There it is. So y to the 6th power. How do we feel? All right. So what's my rule here? AB to the power m. What did you notice? Or I guess if you focus on number 3, you'll figure it out. So if I have a product and I have a power, we're just going to kind of similar to the power raised to a power, but now we just have more stuff on the inside. Yep. Kind of like this. A to the power m, b to the power m. Do you guys see that or no?
Yeah.
Okay. Same thing with this one. So this is going to be, I'm going to use this line as a fraction here. A to the power m over b to the power m. Yeah, you guys look really excited. So don't worry, we'll stop right now, guys. I hope this is not torture. Is this torture for you guys? Okay. Oh, man. Okay. Sorry, guys. I don't want to torture you guys. All right. Multiply same basis. So here it is. What did we do? What did we learn? X to the power m times x to the power n. If you multiply the same basis, all we got to do is what to the exponent? Not multiply, but add. So anytime you multiply the same basis, so base means this. See, they're the same. X to the power m times x to the power n. You're going to add the exponents. Are we cool? Don't worry, guys. We're almost done. Power to a power. So x to the power m, and this is raised to the power n. What do we say we do with that? That one you're going to multiply. X to the power mn. Quotient of powers. Quotient just means divide. X to the power m divided by x to the power n. What do we do? Subtract x to the power m minus n. And I'll put that in parentheses so you guys can know that's my exponent there. And then power of a product and quotient. So I'll put both of these here. So if I have a times b to the power m, that just means a to the power m, b to the power m. And same thing if it's a quotient, a over b to the power m, that just means a to the power m over b to the power m. That's what we just did right here. And sorry that I used AB. I should have used, that's fine. Not a big deal. How do we feel, guys? Are we learning some stuff? Or maybe we already knew this, but are we understanding it? Like logic, not memorize. Okay. All right, here we go. We're going to do these all together, and then we'll set you guys loose with a little coloring activity, mental health. Don't worry, it's with this. You'll see it's not going to be that bad. All right, 3x squared times negative 5x cubed. First thing first. I don't know if you guys might be too young. There's a artist named Iggy Azalea, and she has a song where she goes, "First thing first, I'm the realist." Yeah. I don't know. Maybe you guys weren't born yet when that song came out. But, all right. What's 3 times negative 5? Negative 15. Yeah, you're good. And then I have x squared times x cubed. What am I going to do to those x's? X to the what? 5. When you multiply the same base, you add the exponents. Good job. All right, next one. This is like a 1 in front of that x cubed. I know that it doesn't come out very dark, guys. Here's how it looks. 4 times 1. 4. X to the 9 times x cubed. X to the? X to the 12. No. That's always it's power raised to a power. Yeah, see, that's what good thing we're doing this. Remember, you can always do it like this, miss. You can always do this. You can say 4 and then write like 9 x's. I know it's cumbersome to put like 9 of them in there. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's that one. And then this one's just 3 x's. 1, 2, 3. How many x's do you count? Oh, look, 9 plus 3. That's 12. So 12 x's is 12. You can always do that if you want. All right, here we go. This one, negative 9 times 4. What's that? Negative 36. I have 3 x's on the left, and I'm multiplying, and there's 1 x right there on the right. So that's going to be x to the what? 4. I have 3 y's right here, y cubed, and y squared. What's that? Y to the 5th. Good job. Good job, guys. All right, ready for the next one? Negative 15 times 4. No, you're negative 60. You were one more. You were one ahead. Negative 60, 15, 30, and then add another 30. And then x to the 6 times x to the 5th. That's going to be x to the? There you go. And then y to the 4th times y to the 4th. Y8. There you go, guys. You got it. All right, number 5. This time I have a power raised to a power. There's going to be x to the 12. X to the 12, because we have a power raised to a power. You can always do this. It's okay, guys. It is a safe space. You can always do this. X to the 4th times x to the 4th times x to the 4th. Remember what that means. X to the 4th means you got 4 of them. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. How many do you count? 12. So we're just iterating the logic, guys. All right, here we go. This says to the power 3. 2 times 2 is?
4.
And 4 times 2?
8.
There it is. So that's 8. And then x cubed raised to the 3rd power. That's going to be x to the 9th. Good job. Y to the 4th raised to the 3rd. That's going to be y to the 12. Look at you guys. Look at you guys go. Did you guys have this down on log before or no? But now we do. Now, did you feel your SAT and ACT scores rising? All right, 2 to the 3rd. 2 times 2 is 4. 4 times 2 is 8. And then x raised to the 3rd power is going to just be x to the 3rd over 3 times 3 times 3. Well, let's do the first one. 3 times 3? And 9 times 3? 27. It's okay, guys. This is a safe space. All right, first we look at the inside to see if there's anything we can evaluate or simplify. There is nothing that simplifies, so here we go. M cubed raised to the 4th power. That's going to be m to the 12. N to the 4th raised to the 4th power. That's going to be n to the 16 over, let's see, 3 to the 4th. Okay, let's do 3 to the, I already saved the answer. Let's put 3 to the 4th. Is everyone okay with that?
Yeah.
In a little bit, we'll figure out what 3 to the 4th is. And then p to the 9th raised to the 4th. That's going to be p to the what? 36. Yeah, there's a little trick for the 9s. Do you guys know the trick with the 9s with the fingers? Yeah, you put the 4 down, there's 3 to the left, there's 6 fingers to the right, so that's 36. Put the 3 down, there's 2 to the left, there's 7 to the right, so that's 27. 9 times 3, 9 times 4, 9 times 5, so on and so forth. All right, real quick, 3 to the 4th. Remember what that means? 3 times 3 times 3 times 3. It doesn't matter how you do it. Do you know what 3 times 3 is? What's 3 times 3? Oh, look, I got 2 of those. 3 times 3 is 9, and 3 times 3 is 9. What's 9 times 9? No, Yanni, that's okay. N to the 12, N to the 16th over 81 P to the 36. That's my final answer. If they were to ask simplified, if they were to ask. Are we okay so far, guys? Don't worry, we're almost done, and then you guys can do your group work. You'll wake up a little more when you do your group work. 4 divided by 2. How many times does 2 go into 4? So this is 2. How many x's cancel? 1 x's, so I'm going to have x what? X squared in the numerator, and there's no other y's to cancel, so the y's in the top there. Are we still okay? All right. How many times does 6 go into 18? 3. Positive divided by negative is a negative, so put negative 3. There are no x's to cancel, so 1x, and I have 5 y's in the denominator and 6 y's in the top. How many y's can I cancel? 5, so how many y's you got left? 1. Do you see what we did? All right, we're so close. Number 11. What is negative 14 divided by negative 7? Or how many times does negative 7 go into negative 14? 2. Negative divided by negative is a positive, so there it is. I have 9x in the top, 9x in the bottom. Do all of them cancel out? Yes, so they're all out. Bam, bam. I have 8 y's in the top, 2 y's in the bottom. How many y's can I cancel out? 2, so how many am I going to have left? So there it is, 2y to the 6. Good job, guys. Good job. All right, last 3. Here we go. First, work on this one with the parentheses. So this 2x is that 2x. Parentheses. I'm raising to the 3rd power. So 2 to the 3rd power. 2 times 2 is 4. 4 times 2 is 8. And then x squared raised to the 3rd power. That's going to be x to the 6. Not everyone at the same time. Are we still okay? Oh, yeah, good question, miss. Please keep hitting me. That comes from 2 to the 3rd, which is 2 times 2 times 2. 2 times 2 is 4, and then 4 times 2 is 8. That 2 is that one.
Are we putting all this in simplified version? Is that what we're doing? Because is that what Delta Math wants?
That's what Delta Math would probably do. But I'm okay with you leaving it 2 to the 3rd and then multiplying by the other 2, 2 to the 4th. That's fine as well. What's 2 times 8? 16. I have 1x on the left, 6x's on the right, so it's going to be x to the 7th. You could have also left it as 2 to the 4th. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Are we okay so far, guys? All right, we're almost done. We've got 2 left. All right, first evaluate the inside. I have an x in the numerator. I have 5 x's in the denominator. How many can I cancel out? Well, I should have used the word x. I can cancel out one of them, so that's now a 4, not a 5. Do you guys see what I did? And then I have 2 y's on the top and 1 y on the bottom. How many y's can I cancel out? 1. Bam. So that's now, I guess I'll just do this. I'll just boop and then make that a 1. All right, so here we go. It says third power. So y to the 1 raised to the third, that's going to be y to the third. And then I have 4. I guess I'll write first 4 to the third. X to the 4th raised to the third power, that's going to be x to the... not the third. That's x to the 4th to the 12th. And that's it. So I guess let's simplify the 4 to the third. Y cubed over 4 times 4 is 16. And 16 times 4 is 64. I know. We're all tired, guys. We'll stop in a little bit. Are we still okay, guys? All right, last one. Here's my x squared. Leave that alone. I'm going to raise that 5 to the third power first. 5 times 5 is 25. And 25 times 5 is, I don't know. Yeah, there's the way I see it. Whenever I hear 25 times 5, I think of quarters. And I'm like, if I have 5 quarters, what do I have? Oh, $1.25, so 125. X cubed raised to the third power. That's x to the?
11.
No, not 11. 9. Oh, you're giving me the final answer. Okay. Are we still okay? I have x squared on the left, and I have x to the 9th on the right. When I multiply those two suckers, I'm going to have what? How many x's? 11. So there it is. That's my final answer, guys. How do you feel?
Good.
Do you feel...
My scores are rising.
Yes, 100%. Like, did you learn it like this last year? All right, we have one little activity. Take a 30-second break. Don't worry, guys. This will go faster because you're in groups and you're gonna. I know. Well, some of you can sleep. Get some sleep tonight. They're both about the same. So from here, it doesn't matter which. No, they can go at the same time. It's better. All right, guys, don't worry. We're almost done. I'm gonna do 2 of them. And relax, Chav. We didn't talk about -1. Like we kind of did, but we didn't really. Chav, but we didn't talk about all these. Look, we're gonna do them together, and then you'll get the hang of it, and you can work together as a team. And whenever you get stuck, you can just ask me. It's not a big deal. All right, so check it out. Chav, we didn't do stuff like this. Relax. I see 3 to the -1 right here, and I see 3 to the 4th. And I remember, since we're multiplying this, I can just add up the exponents, right? What's -1 plus 4? 3. So there's going to be 3 to the third times 5 squared. The little dot there. If you want to put it in parentheses, you can. Let's see. In the bottom, I have this 3 squared there. And then 5 to the third times 5 to the 0. 3 plus 0 is still 3. So that's going to be 5 to the third. By the way, anything raised to the 0 is 1. So you could have also done it that way. We're still not done. That's just... I know, if in case you already have mastered this, you're probably saying you're doing too much work. And you're right, but relax. Like, not everyone's at that level. All right, you guys ready? I have 3 to the third power on the top, and I have 3 squared in the bottom. How many 3's can I cancel? 2. Bam! So that 3 to the third turns to 3 to the power 1. Do you guys see that? I have 5 squared in the top, and I have 5 cubed in the bottom. How many 5's can I cancel? I can cancel how many of them? 2. So now that 3 turns to a power 1. So now here's what I have. I have 3 to the power 1, which is 3, and then 5 to the power 1, which is 5. Is there a 3/5 in here?
Yes.
Blue. Whenever you see blue in the back of this page, you're going to color it blue. Cool, right? All right, let's do number 5. because number 5 has this 2 right here, and that's like the power. So remember what we're going to do. A power raised to a power. You're going to multiply it. So YC, I'm gonna leave the parentheses there alone. So I'm going to have 2 to the power 6, like this. 3 squared, 2 to the negative 1. All over 3 to the 6. I haven't changed anything. 2 to the 4th, 3 to the negative 2. Are we still okay, guys? Okay, don't worry. I'm gonna go slow. So I have 2 to the 6. I see that 2, and I see another one right here, 2 to the power negative 1. When I multiply these two, where do those exponents? You what? That's the letter A. When you multiply, you add them. So what is 6 plus a negative 1? 5. So that's 2 to the 5th times 3 squared. Don't worry, in a little bit we'll simplify. I see the 3 here, and I see a 3 here. I'm trying to combine my bases. So 3 to the 6 times 3 to the negative 2. I'm going to add those numbers up. 6 plus negative 2. 3 to the 4th times 2 to the 4th. Are we still okay? Don't worry, miss. We're done right now in a little bit. All right, here we go. Last. I know we're tired, guys. I'm going to take a nap as soon as this class ends. 2 to the power 5th. Look, I have 4 of the 2s. 2 to the power 5th over 2 to the power 4th. How many 2s can I cancel out? 4 of them. So there it is. I have 3 squared in the numerator. I have 3 to the 4th in the denominator. How many 3s can I cancel out? 2. Bam. That one goes away, and I have 2 left. Do you guys see what I did? All right, so here's my answer, guys. I have 2 in the numerator, and I have 3 squared. What's 3 squared? Is there a 2/9?
Yes.
So there it is. Chav, where are your markers and your colors? If you look back there in the teacher desk, you see below there, it says colored pencils, and there's markers down there as well. So there it is, guys. You can work as a group. Try to finish this if you can today. If you can't finish it, you can. But I would like for you guys to do the coloring because mental health. Coloring is fun. And that's it, guys. Work on this together. And let me know if we have any issues, guys. I'm going to pause this momentarily until we have a question. You guys ready? All right, so here we go. Number 6. So the first thing I'm going to do on this one, I'm going to work on with this. And you can do whatever order you think is best for you, but I'm going to work on that one right there first. So I have 3 to the 6 times 3 to the negative 8. Does everyone see that? Yeah, can someone open that door for her? Times 5 to the 6 over. And then this right here, those two right there, that's just 5 to the 3rd. 0 plus 3, or you can say 5 to the 0 is just 1 times 3 squared. Okay, these two right here that I'm circling, 3 to the 6 times 3 to the negative 8, that's going to be 3 to the negative 2. Do you guys see that? Or no? Okay, so I have 3 to the negative 2, and then I have times 5 to the 6 over 5 to the 3rd times 3 squared. Are we still okay? Okay. So I can cancel 3 of the 5. So there's 5 to the 3rd. So that's 5 times 5 times 5. And on the top, I have 5 to the 6th. So 3 of these go away. Bam. So if 3 of those go away, I have how many left? I have 3 of them left because it says 5 to the 6th. Well, I should also be more clear in my communication. I have 5 to the power 6 divided by 5 to the power 3. 5 times 5 times 5. 3 of the 5s cancel out. And I have 6 left. So 6 minus 3. I have 3 now left. Does that make sense, guys, or no? Okay, so now what do I do with this? That 3 to the negative 2. I can do negative 2 minus 2 if I wanted to. I mean, that's fine also. Or I can bring it down and it turns positive. So I could do this. 5 to the 3rd over 3 squared times 3 squared. That's not the only way. That's not the only way. I'm just doing one method. You could also do negative 2 minus 2, and that would be negative 4. You can bring that down. So look what I have. I have 5 to the 3rd over 3 to the 4th. Are we still okay with that, guys? All right, 5 to the 3rd. 5 times 5, 25. 25 times 5, 125. 3 to the 4th, 81. 3 times 3 is 9, and 9 times 9 is 81. Is there a 125 over 81? All right, there it is, guys. And that's one of the harder ones. I don't think they're going to get much harder than that.